Welcome to my fifth video, still in the first main chapter of our video series about making a action RPG inside of Unity. This video is going to cover some very important topics such as getting the camera to follow the player and fixing this overlapping issue where the player is appearing on top of things and the fact that I'm not even behind a tree. So let's begin and take a look at that. So first up, we're going to start tackling the settings on the main camera. And really, there's not a whole lot we need to do here. I will probably recommend bumping the size up to 6. But realistically, there's there's going to be nothing inside the code that's going to prevent us from changing the size. So the size is pretty much up to whatever you want. I would recommend being consistent across different scenes because if you have a super zoomed in and then a super zoomed out map, it's not going to be very fun. So a 6 is a pretty good one. The only other thing we could consider is the clear flags because should the camera snap to position, there's a small chance you might see the stuff behind the scene. So, and you can even see on this preview here that before the camera adjusts itself, we've got some of that, the void essentially. So it could be worth just setting it to black because that's a pretty fair thing. Like if you're not seeing anything, just let it be black. We ideally should never see any of it. You can see this black bar right there. But, you know, I think black probably works. And then we'll see if we end up getting the tearing on the tiles because we're going to eventually have to fix that. Once the camera starts moving, we'll see tiles tearing. Alright, so that's really the only settings we have to play with on the camera. It has an audio listener, so that when we add some sound effects, that'll be the point at which hearing occurs from. So, kind of an interesting thought of maybe you'd want to move the audio listener to the player, but we'll play around with that when we start doing audio. So, let's add a script for the camera. So, under the scripts folder, I'm probably going to make another subfolder called core. And these are for some of the core gameplay things that aren't specific to puzzles, players, enemies, projectiles. So inside of core, I'm going to create a C# script and call it camera follow. Or camera movement might work as well, but camera follow makes sense. And then we're going to open that script up. So here's our camera follow script. So we basically need to start specifying what it's going to follow. So that's going to be our first variable, public transform. Not using a game object just to make things a little bit easier. You could just use a game object if you want. And so a new command that we haven't seen before is the tooltip. And tooltip will allow us to give a mouse over description when we're looking at this in the editor. So I've made my tooltip say optional, attach an object to follow, usually the player. So if you don't specify something, the camera's not going to move from its initial location. If you do specify something, it's going to follow that object. And then to control the edge of the screen, we need to get the tile map. So public tile map. Now you'll see that tile map didn't change colors. And that's actually because we need to import Unity engine tile maps. And you can see it being added up here. Let's add a tooltip for this because this is going to be something that the developer has to define. And I'm just specifying what the purpose of this is, that you do need this tile map, otherwise this is not going to work. And then just some internal variables used for some of the calculations that we're going to do. So the camera positions. And we'll make these ones public so that we can access them. just in case we ever need to figure out the edges of the world. We can always request the main camera, and then we can pull those. So then we need the orthographic size for like the zoom level, and then we need the aspect ratio, because that's how we're going to calculate the X and the Y edges. The ortho size is going to dictate essentially the Y height of it, and then the ratio is going to determine the horizontal limits of the camera. So just kind of specifying there, because that's what we'll pull them from the camera, but we still need to keep track of those. Basically, a reference to the camera script. Then the smooth position is the destination to go towards as it's chasing the player. So it's kind of like a temporary position. And then I guess up here, let's add this as public float smooth speed. This is how quickly the camera is going to follow the player, because we don't want it to like immediately just set its position to the player, because that looks kind of jerky. We want it to kind of like slowly pick up and slowly coast to a stop. So this is the speed at which it's going to do that, because we're going to be using a linear interpolation called a lerp. So this is a value between 0.0 and 1, how quickly to move to the player. Higher numbers are faster. So now that we have these variables, we have tooltips for the public-facing ones. This is actually just public so that other scripts can just access these if we need to. Like let's just say you shoot a fireball. Once it leaves the edge of the world, you probably safely can delete it. All right, so now let's set up and attach all of these variables inside of the start. Hit save just so it commits those. So if the follow transform is not equal to null, we're going to set the camera's position to exactly this. Oops. And I'm doing a vector 3 just so the camera doesn't lose its Z position, because if the camera jumps to the same Z position as the thing it's following, it will be at the same height as the board, and that will not work out in anybody's favor. You'll notice that this last one is not the follow transform. This is actually the camera's Z position. And you can see that I just marked that there. So we're going to immediately jump if something is defined to be followed, we're going to immediately jump to that thing. We'll add this as kind of a backup. If the map is null, because if map is not defined, we can't do anything with the camera. We will attempt to find GameObject.find the thing called ground and get the component tile map out of it. So worst case scenario, if we don't have a map defined, we can still try to grab it. So then we'll determine the edges of the world. So if we do xmin equals map dot, and then there's a lot of useful things here. There's local bounds, and if we read what that says, returns the boundaries of the tile map in local space. So that's going to get the x and y positions of this map. So local bounds dot min x, and so that's going to give us the lowest x value. And we're doing this because we're not going to, none of the maps are a fixed size. Maps can be in any size that we want, so we need to dynamically determine where the edges of the world are by just pulling it from the ground component. That's why it was very important when we were setting up our grid that if we look, this one is the most important one to have defined because we're going to be pulling basically the size of the stage from ground. You'll even notice that my cliff faces are they're sitting on top of the ground. And that's because, again, if they're sitting off the ground, they're not going to be used in the calculation for where the edges of the camera are, and you wouldn't actually see these. So it was very important that I put my cliff edges on the actual ground part. This board is what's going to establish the size of our camera. And if you have any weird oddities, like let's say the camera is willing to show one extra row of nothing, you might have to go to ground, go to tile map, and then tell it to click the little triple dots and tell it to compress tile map bounds. Like if you drew some extra tiles and then erased them, you can see the bounds right here with these little handles. The bounds might still include that empty row. So something to kind of watch out for. And so that's where these are getting pulled from. We could even have it spit these out. It's a long string concatenation here. Which would be safe to skip, but it is an interesting thing to see. So this will tell us the actual x and y coordinates of our thing. And then let's just define the rest of the variables. So we're going to need to grab the main camera. We need to get the orthographic size. So this is the zoom level, essentially. And then we need to get the current aspect ratio. So if you're playing on widescreen versus more of a rectangular resolution, and it can just pull this pretty easily. So aspect gets that, and then if we multiply it by the ortho size, that will get the x distance that we need for the width of a screen. So we can save on this. And I think we can actually just attach it now, because then we can take a look at this debug log stuff. So it's compiling, and let's take camera follow, slap it onto main camera, and you can see that we've got these pieces here. I'm curious to see if it will even correctly grab the ground. I think it should. So if we don't define ground, you can see that it's specifying my ranges. So if I pause here and we take a look at player, we can actually see his world position right here is because like I can't get up to the edge, is negative 8.6, and my thing's saying that my lowest x is negative 10, the highest x is 20, and that looks about right. if my player goes down here, as close as I can get to this bottom corner, my Y position is -5. That's a little bit interesting. What if I printed out the wrong thing? I think I did. So I just copy and pasted it. Alright, so back to this. So now you can see that saying the lowest Y that's possible is -6, the highest Y that's possible is 13. So being able to see that, that's going to be what helps me control my camera. Because that's going to be where I can define where the edge of the camera is allowed to see. Extremely powerful for it to be able to detect the edges using a world space of my board, so I don't have to ever define that. I just have to be careful that ground is a complete tile. Anyway, back to here. Let's attach the... Well, let's leave it blank for now, because we're going to turn it into a prefab. So I'll leave those blank for now. All right, inside of update, well, I guess we're doing positions, so let's do a fixed update. So if map is not equal to null, so as long as map has been defined, and follow transform is not equal to null. And I'm just checking these just to make sure that, like, if the player gets deleted for some reason, we don't try to find where the player is. Or if the map was failed to be defined, don't do this. So two different things. They both have to exist for us to try to update this position. So first up is, I guess let's do the smoothing first. So smooth position is a vector 3 lerp. And we're going to go with this transform.position, which is my current position of the camera, to let's see, transform.position Z. So we need to oh. What is bad? Oh, then we need one more position. We need the smooth speed. Okay. So what lerp is going to do, oh, I guess let's define camera X and camera Y. Those are our desired positions for the camera to go in. So that we're basically, this is my starting position of the camera. This is the target position of the camera. So we'll do the camera X. And we're going to use a math function called clamp, which restricts it between two different values. So the follow transforms X position, and that's what the value that we're, so you can look at this, that's the value we're looking for. So, and then the min, what's the lowest allowed position, what's the highest allowed position. And that would be the edge of the map plus the camera ratio, which is essentially the distance from the center of the camera to the edge of the screen. Because if we allow the camera go to the minimum to be X min, the center of the camera would be on the edge of the screen. Half of the screen would be empty. So this camera ratio is the half distance from the center of the camera to the side of the screen. And the same is true for the max bound. It did take me a while to figure out the math behind all of that. So while for this video I'm just doing this relatively quickly, the math behind that was a lot of experimentation until it worked. And then we calculate the Y position. So we're basically setting the camera's goal positions to be those. And just to clean up this next line, and we're going to create that goal as a vector 3. So we'll call this vector 3 camera goal position. And we'll just take what we had written here, just so that I can make my lerp command a little bit easier to interpret. So what's going on with this is it's an interpolation between 2 points. So we're saying that we've got a point A and a point B, and the position that we're going to end up wanting to go to is going to be between these 2 positions with a factor of smooth speed. If smooth speed is 0, it's going to be this position. If smooth speed is 1, it's going to be this position. So in some ways, you can think of lerp as a type of midpoint formula that gets you the midpoint between 2 different points based on a certain factor. Like if this is 0.5, it gets you the midpoint. If it's 0.75, it's 75% of the way towards this position. So it just gets you points on a line in between 2 locations. And so then we'll just assign the camera's position. So, let's see this in action. This should be completed. We got comments so that we can remember what all this does. Maybe I need a few to denote the ending of my methods. And start and end fixed update. Okay, so let's see what that looks like. So we've got my camera here. These might be public variables, but they will get calculated behind the scenes. Like if we hit pause, we can actually see those values getting populated. And it actually filled in the ground map. But we didn't actually define the thing to follow. So at this point, before I define that, I do want to make this thing into a prefab. So let's go to prefabs, go to create, new folder. I'm going to call this core, like I did before. And I'm going to take my main camera and I'm going to drag it down into the core prefabs. So that way when we start building new scenes, we can very quickly get that thing going. And you can even see my tooltips work. If I mouse over stuff, it'll say optional, attach object to follow, usually the player, required, attach the ground tile map here, smooth speed, and it's all that stuff's there. So this main camera, let's link in the player, wherever the player is. I'm going to follow the player, and I am going to link the ground manually like that. So we can hit play, and we can see that the camera does jump to the player right at the start, and now we've got a the camera is able to follow the player. So we're actually able to see the rest of this map for once from the perspective of the player. I did put my little blocking things here. You can see that I've allowed the player to only exit from there. And we're kind of getting to that 30-minute mark, so I may end up covering the doodad overlapping in the next video. We're gonna have to fix this guy too. But that kind of gets our camera working. We've got bounds. If you want to change your aspect ratio up here, you can actually change this to different things, and Unity will, the camera edges should still work and behave correctly. Kind of looks like that one's getting a little extra tile on the edge. So, but yeah, that gets our camera working. And actually that could be the argument for leaving this to be something other than black, so that if there is something on the edge, we'll be able to see, and then we could like figure it out. But when it's all done, I'd switch it back to black, because you could see that blue bar on the side looked kind of ugly. On the free aspect, though, I am getting a little bit of a view of that. Probably has to do a few guesses as to what could be causing that. Probably because it's not calculating the horizontal bounds correctly of the camera. All the other aspects work correctly. So, I don't know, free aspect is kind of a weird one. So, correct camera following. And so I guess I will see you guys in the next video for where we get these tooltips working. So thank you for watching.